in Excel, and this can also come to provide some level of insight as we work it with our own data or different challenges at work every day. I believe that this can come very helpful and useful. At least just provide some kind of intuition. Oh, I've solved a problem like this before. So how do I use that knowledge to solve new problems and so on? So that's the kind, just to kind of stimulate how we think as we go into the new year. And I feel like some of the lessons I learned this year using the median function in some ways we can also find very useful in other areas as we work. So I'll just go straight into it. And if you have any question along the line, please don't hesitate to ask. All right, so I'm sharing my screen right now. All right. Okay, so let me know if you can see my screen. I think I'll just unmute you briefly so that you can respond. All right, so can you confirm to me that you can see the screen I'm sharing?
Yes, you can see it. You can see your screen.
All right, great, thanks. So I didn't want to reinvent the wheel. Around the brain already did a very good job of explaining how the this function works. I mean, the median function, very simple, is basically to just find the median of given numbers. You have a set of numbers. You want to find the middle value. It's also one of the measures of central tendency, like we know from our elementary statistics. Measures of central tendencies and so on. So basically, that's what the median does. So the question now is, okay, how can we now find out more useful in our everyday work so that we get the best out of it, out of using the median? Instead of writing very long formulas, you will see how the median can actually just help to, shorten things for you quickly, and then you get a lot more done. So I'm not going to go over this again. I'm acknowledging around the brain. This just is a screenshot from Excel Bible function around the brain. So I'm not going to go over it again. So simple example. Sorry, spilling some numbers here. Okay, there you go. So I have this set of numbers. I think there are 22 of them. Okay, and then to find the median is basically to just look for the median. Of course, I'm using the spill, what's that word again? Operator. That's the hash for that range because it's spilled. I'm just generating some random numbers here. Using random array to generate random numbers there, and I'm trying to find the median. All right, so we could just do the median of those numbers, and it gives us that. And also, the median is the same thing as the 50th percentile when you are using the percentile. For percentile, you can find the 5th percentile, the 10th percentile, 75th percentile, 90th percentile. That means what number falls on the on 90% of the total numbers that you have in a range. All right, so that's what percentile is. So you can find the 50th percentile using 0.5 here, and it will give you exactly the same thing. Median is the same thing as 50th percentile, and it's also the same thing as second quartile. All right, that means when you have a set of numbers and you call them into quartile, it's just a quartile is looking for the 25th percentile of a range of numbers. Okay, so you have the first quartile, second quartile, third quartile, and you have the fourth quartile. We have also heard of quintile. It depends on which area you are looking at numbers, but basically that's what the median does. So it just finds the middle number. If you have 1, 2, 3, all right, as a number, if you find the median of this, which number is in the middle? All right, so it will always be 2 in this case, and you don't have to arrange them that way. It could have been 3 here, 2 here, and you have 1 there. All right, it will always be 2. So implicitly to arrange them in descending or ascending order, and then find which number lies in the middle. We know all of these things from elementary mathematics. Okay, and of course, if the numbers are even, odd, like in terms of number of counts, like these odd, there are three of them, so it returns the one in the middle exactly. But if they are, say, let me take this down. If they are even, for instance, if I have, let's say this just 2 and 3 here, so it will find the average of the two numbers in the middle, and then it gives you that. So that's why you have 2.5 here, etc., etc. So that's what this gives us. So that is basically what the median does. So I'll just show you a little bit more, some of the ways you can use the median to solve a couple of problems that you may find in real life, apart from trying to find the median. Of course, one of the ways you also find the median very, very useful is sometimes you have outliers in a range of numbers. Sorry about that. So sometimes you have outliers in a range of numbers and you're trying to find the average. Okay, for instance, you have numbers, say 5, 6, 7, and then you have a number like 29, something like this. If you find the average of these numbers, it will be skewed upward because now it's saying the average is 9.4. But you agree with me that that is not really a very good measure for this number, of course, because it has an outlier. So this is the average. Okay, so I think I should stop this. Okay, let me just leave them. So because of but of course, when you have the median, when you use the median to find the average, okay, the measure of central tendency for this, it says it is 5. All right, because there are 5 numbers here and there's a median. So in this case, it is skewed because of this outlier. Yeah, there are so many use cases for using the average to measure outlier, comparing the median and the average. When you compare the value of the median and the average, it tells you in which direction the number is skewed. For instance, if you look at average of salaries of maybe people in an organization, and it is kind of skewed upward, like very skewed upward, it tells you that people in senior roles earn way more than people in junior roles. That's just one way of interpreting such a number, and so on and so forth. Okay, so median can also help you to take care of outliers. You have a very huge set of numbers, and then you want to find the average, which in this case you could use either the median. In fact, in some statistics, would rather use the median than use the mean, because the median tends to provide better insights to non-number, especially numbers that have outliers. So let's look at some of the use cases that we might find in real life. One of the use cases that we can find is when you are trying to prevent non-negative numbers, all right, in a particular range. For instance, you have these values say 15, 4, and so on and so forth. And then you are looking at the difference between them and say 10, or maybe the average, all right? Now, you want to assign a score to them, and you want to say, if this number, that's 15 minus 5, 15 minus 10 is 5, all right? But 4 minus 10 is negative. Now, you want to prevent the outcome from being a negative, and then you want to assign, say, a weight to say that if the number is, say, greater than, if the number is less than 0, then return 0. But if the number is, say, less than 10, then return 10. Or if the number is, let me take that again. If the number is negative, that's then return 0. But if the number is greater than 10 or above, then make it 10. So you have kind of restricted what you want to return in that case. I'll give you a real life example of how we use stuff like this shortly. So in this case now, I'm saying the number is between 0 and 10, then return that number itself, which is 5. If it is less than 0, like in this case, then return 0. If it is still between 0 and 10, return the number, which is 8. Now, if the difference is above 10, then return 10. Okay. So one of the ways you would have written something like this is maybe write, if this is less than 0, then return 0. Else, if it is greater than or equal to 10, then if D9 is greater than or equal to 10, all right, then return 10. then give 10 else, give me D9. Okay, so it's possible you will write a very long formula like this to solve a simple problem like this. But now with the median, it kind of shortens the whole thing to just one formula, one function, which is using the median, and then restricts all of the values to between 0 and 10. So that's one of the use cases that you can find here, where you are sometimes assigning weights. One of the ways I've seen that used in real life is maybe when you're calculating incentives, all right, for people. For instance, maybe these are sales reps or a particular shop. They already have, this is the actual revenue that they made from their sales. These are their sales targets. And then you have looked at what they achieved. All right. Now, based on their achievements, you want to calculate incentives for them. The achievements will be between 0 and 15%. All right. So if you make say 90%, your incentives starts from 90%. If you make say between anything below 90%, you won't get any incentive. All right. But if you get anything 90% and above, then you begin to get incentives over 90. All right. So your incentives are based on whatever you get minus 90, and then it's restricted to at maximum of 15% of your total revenue. Okay. So that means if I'm making 90%, okay, let me just explain that briefly. So let's say I made say 91% in my revenue at some point. Okay, so that means I've done 1% over 90%. So that means I'm getting 1%, 1% of whatever I get as my total revenue. Okay, and that means I'm getting 1,549 naira as incentive, right? Or bonus, or sometimes we'll call a bonus, for that period. So that's one of the use cases I found for using this weighting system that you have here. So instead of writing multiple if functions, so if this happens, then do this and all of that, you could actually just write a very simple formula that says, okay, find the median between 0, that means minimum is 0. In the middle, you have the difference between whatever you get and 90. If the number is below 90, all right, which in this case would be negative, you will not get anything. It will just give you 0. Okay. If the number is greater than 0 but less than 15, you will get exactly that. But if the value is above 15%, then it will just truncate it back to 15%. So let me show you an example of what we're saying here. So for instance, this person has achieved 181% of their target. That's this divided by 200 is 181%. In that case, they qualify for 15% of their total revenue. Okay, this is what I've done here is just to help to break it down so that we have an idea on what we're looking at. So this already 90%. Let me just recalculate the sheet so that it gives me something that is not. So it gives me something that's okay. I'm trying to see. The numbers, they are so huge. They are not really falling within the. Okay, let me make it between these and say 210%. 210,000. Okay, let's see that. All right, so I think this is a better one. So great. So you will notice this is 102%. Okay, and this person is getting 12% incentive. All right, so that is 90. This 102 minus 90 gives me 12%. So that's how I got this 12% here. All right, but because this 84%, 84 minus 90 is negative. So that means the person is not getting anything as incentive, and so on and so forth. This 91% achieved, that's just 181 divided by 200 is 91%. So the person is getting 1% incentive. And the formula we have used here is just the median 0. That's and then achieved minus 90%. All right. And then you have 15% as a maximum you can get. And so it will always just truncate whatever you get in that range. So it's one of the ways I have seen the median being used. Do I have any question at this point before I go on to the next thing? Any question at this point? Any question?
Yes, sir. I have a little confusion here.
Yeah, please go ahead.
All right, sir. Um, so by using this one function, we don't need to specify the amount of percentage that the person will get. It will automatically be calculated. Like
Yes.
if the person gets let's say 150%, so the incentive will
Okay.
automatically be shifted to whatever
50.
corresponds with 150%.
Yes. It will automatically shift to whatever you get above 50%. In that case, 150%, which let's even try that and see what it does. So let's say this let me put something that will give me 150. So all these are spewed. Okay, let's do it this way. So let's say this is 150%. Okay, so 150% here,
Okay.
and this will be 150% minus 90%. All right, that's 60% above 90%, right? So normally I should have just done 60% times whatever you get, but we know that the maximum we can give you is 15%
15.
of your total revenue. All right, so
Yes.
what I'll just do is median, zero as the minimum you can get, and then your 150% minus 90%. Okay, and then the maximum we can give you is 15%. So if the difference between your 150 and 90 is more than 15%, you should just truncate it back to 15%.
Okay.
You
Yes.
get right. But if what you have here is, say, maybe what you have here is 105%. Okay, I think it's okay. That's already above 15%. Let's say what you have here is exactly 100%, right? So it gives you 10% automatically. All
Okay.
right. So it
Yes.
gives you the actual number. It doesn't take it above 15. It doesn't take it below zero.
Okay. It's understood now, sir. Thank you, sir.
Yeah, great. So that is so one of the use cases that I found for the median, and this is useful for calculating incentives. It's useful for weighting. For instance, you want to calculate weights, you want to assign weights to certain numbers for a particular type of calculation. I can't really remember a specific example now, but I think I've experienced such before, where you just need to assign weights to numbers, and then you know that the weight cannot be above this and cannot be below this value. So whatever it happens, it will always fall within these values. Then you can use that to calculate such, and so many use cases for this very simple formula, which like what we had here. Yeah, something like this, where you just have, it will always find the median of these three numbers. Anything that falls below zero, zero becomes the median. If the number is above 10, 10 becomes the median, and so on and so forth. So it's one of the use cases I've found for that. So lastly, using the median to create a Gantt chart like this, all right, it's still the same concept. I will rebuild this from scratch and then show you how it's done. Okay, so I use the median function to create this Gantt chart so that it's dynamic, so that when the numbers change at any point, all right, the median can easily take care of that. So for instance, if this was say 3rd of December 2022. All right. So you see the Gantt chart automatically expands to take care of that. And if this was, say, 27th of December 2022, the Gantt chart will just shrink and then move in that direction. So that's, I kind of like this because it helps you to be able to quickly create Gantt charts for project management, for tracking activities, for tracking leave. Maybe people are going to be on leave at a certain time. All right, like I think I use this kind of example for a particular leave tracking and all of that. So, when is it starting? When is it ending? Or in project management and so on. So, I think using the median can really help you to quickly do that. So, how do we build this from scratch? So, I'll just Hello, so sorry. I think my internet just went off and I didn't know. So sorry about that. So I'll take it from where I stopped. Okay. Yeah, so sorry about that. Please, can you see my screen?
Yes, we can see it now. It's back.
Okay, great. So I was talking about the Gantt chart, how you can use the median function to actually just create a very lovely dynamic Gantt chart, so that you don't have to like go through trying to, you know, highlight things from scratch. You can easily just use the median function to create a Gantt chart like this, and it will be very, very dynamic. So let's see how we can do that. So so let's say we have stuff like this, where you have, it could be name, it could be task, it could be anything here. All right. And then those are just listed downward that way. And then you have, I'll come back to number of days, is the difference between these two. Okay. So you have the start date for the activity, you have the end date for the activity. Okay. Or it could be a leave day, it could be anything. And then on the left here, I have the difference, number of days. All right. What's the number of days between the two of them? I'm using network day in this case to calculate the number of days. Network days international, so that I can also account for holidays. All right. Actually, we're not talking about network days particularly today, but let me see, where did I put the holidays? I hope I didn't create a space. I know I hid the holidays somewhere where I can't just. Okay, maybe I put them on a hidden sheet or something. Let me see. No, not this one. Yeah. There you go. So I have these holidays that I already put here. These are the holidays: 25th, 26th, 27th, 1st of January, 2nd of January, and so on. So we're not really talking about the holidays today. I mean, the Network International today. But what it does is it finds the number of work days, because I'm just tracking work days, number of work days between two dates. All right. So you have the start date, the end date, you have weekend, and then what kind of weekend? Saturday and Sunday will be weekend, or Sunday, Monday. You can please study more about network days. And then if you have holidays, a list of days that are holidays, so that the system can also account for those. So the formula will account for holidays. What I did was to create them as a named range, so that it will be easy for me to quickly call them up. So holidays, I also named them holidays. So it will account for holidays in the list, so that it can effectively tell me how many work days are between the two periods. For instance, I think this is third of January, 3rd of December was actually a Saturday. So if I say the activity will be between the 1st and the 5th, so let's say the 1st of December and the 5th of December. All right, so you can see 3, because there are actually 3 work days between them, and so on and so forth. So I don't want to go into that right now. So I'll just leave it at that. Okay. So what we're trying to do now is to try to create a formula that helps us to be able to tell that this, to tell the start date and the end date. And basically what I'll just do is to say you should find the median of the start date, which will be the lowest number there, is this. All right, let me fix that. Let me just fix the column. And then this one comes into the middle. All right. Okay, there you go. Fix that. And then the end date. Really, it doesn't really have to be in this order, because the median function is intuitive enough to know. It doesn't have to be the start, the end, and all of that. They can be arranged in the median function anyway. It will always come up with the correct number. So, and then, yeah, it gives me a date. But what I want is it to be able to give me 1 or 0. So where this is the median of the 3, it gives me 1. If it's not the median, then it gives me a 0. All right, so I can say this is equal to this. Okay, so I'll fix that also. I'll fix the row. Yeah, I think I need to fix the row for this. Okay, there you go. And then to give me 1 or 0, I can just, but this will just give me true or false. For instance, if I put F9 on this, sorry, let me take this out first. So if I do an F9 on this now, it gives me a false, all right? But I need to just give me a 1 or 0. So I'll do this equal to G3. Okay, I'm fixing the row. Let me fix the row for this one also. Okay, let's just say plus 0. Okay, there you go. It gives me 0. So because this value, this date is not the median for these 3. So it gives me 0, all right? So if I drag this formula to the right, see what happens. I have 0 everywhere except here. The 1st of December falls as the median between these 3. Why? Because look at this formula now. Let's open the formula up. Okay, so here I have E4 is 1st of December. Q3 is also 1st of December. And then F4, which is the last one, is the 5th of December. So I kind of have 1, 1, and 4. In that case, the median will be 1. All right. The median of 1, 1, 4 is 1. That's the number that falls in the middle of the 3. So that's why we have that. So because this is in the median, it gives me 1. This also median, this also median, this median, this median. This is a median of 1, 5, 5. So when you have 1, you have 5 and 5, and these are 3 numbers. So the middle number is 5, so it gives me the 5th. Because 6 is not in the middle, it's not the median of, because don't forget I've put a cap on it. The maximum number here is what's it called now? The median for 1, 5, and 6. I'm using those numbers so that it will be easy for you to easily grasp. The median of 1, 5, and 6 is 5. But 6 is not the median, it's not equal to the median, so it gives me 0. So when the date is below the start date, I get a 0. When it is above the end date, I get a 0. But when it is between the start date and the end date, I get a 1. All right. And so if I drag that all the way to the right, okay, if I drag that all the way to the right, okay, I get zeros here and there. And if I drag it all the way down, okay, I get the 1s and 0s in different places. Let's change some of these ones so that it can become more intuitive. Let's make this 19th of November. Okay, 19th of November. And then let's make this 4th of December. Okay, something like this. Sorry, 2022. Okay, so to make it easy to see how the numbers are moving around, I'll just use conditional formatting on them. So usually what I'll do is, if it is 1, highlight the cell. Anything beyond that, just make it blank. All right, so I'll say manage rules, new rule. Cells that contain equal to 1, sorry, equal to 1, format them as, let's make it this blue. All right, so, and then new rule, cells that are not equal to 1, right, don't just make them white or something like that. Okay, just make them white. That's what I can think of right now. I'm sure there are, sorry, no fill, no color, and the font will be white. All right, so that it kind of just disappears into the background. Okay, and then if I apply this, okay, yeah, let me change the font color of this one. The font color will also be the same blue as that. All right, so you see everything just disappears, and that's it. So that's one of the ways you can use your the median to create something like this. So that's one of the use cases we can find for the median function to create a Gantt chart that looks really as nice as this. I mean, and it's really dynamic. For instance, if I change this to say the 1st of December, and then this one ends on say 11th of December, say 11, 12, 2022. Very dynamic. Everything just moves in that direction. Oh, sorry. 11, 12. Okay, you can see how dynamic it is. So this is one of the use cases you can find for the median function. All right. Basically, what you're looking at is, does this number fall in the middle of the start date and the end date? If it does, give me a 1. If it doesn't fall within the period, then give me a 0. And then you have your dates spread out like this. Sorry, I won't talk about how I got these dates really. But what I've just done here for this date is to find the maximum, the minimum date in the start date and the maximum date in the end date, and I use that to create a sequence of dates. All right, between the maximum date in the end date and the minimum date in the start date, and then that gives me. So that's why this also kind of dynamic. All right, so if I change, so if you the maximum date here, oh sorry, to give me as a number. So I find the number of dates between minimum and the maximum date, and then the sequence will start from the minimum date, and then it will come out as integers. I'll format them as dates. So that's why this is pretty dynamic. For instance, if I make this say something like 1st of November, so that the date will just expand that way, so that it takes in more, and everything is pretty dynamic. So that's one of the use cases that I've also seen for the median. And of course, you could also use LAMBDA to solve the problem by column instead of dragging the formula all the way through. Right? I have to drag the formula all the way this way and down, which that's not really very efficient, especially now that you have spilled ranges, you have array formulas and all of that. So you can also, but you understand the basic principle of why this was done the way it was done. But so you can also come here and have this done with array functions. Here I use by column. Let me just open that up. All right, so by column, so it's to just go through all of the columns, so that if it shrinks, if the columns change, then it shrinks with it by column, and then you bring in your lambda. It's just the same formula as what you had there the other time. The only thing that is different from, you will note your X here, all right, is like the by column refers to this array across the columns, all right, and your X here is referring to each of these. This is just an error check to be sure that D4, that means this is not 0. If this is 0 for any reason, then yeah, it gives me 0. It just knocks out the entire result. That's just an error check. But this is the core of the result. This X is equal to, which is what we have done, X is equal to the median of this A4 and this and that. So the only thing I've done here is just drag the formula down. All right, drag the formula all the way down. All right, with as many rows as I may have, which of course we can also make that dynamic. If as these ones increase, the formulas also spill across the rows and across the columns. But let's leave it as it is for now to avoid further confusion. So this is basically what I would like to show you today on how some of the ways you can use a median function, just expanding on basically understanding the properties of the median function and how you can use that to solve some other problem, such as creating limits on incentives or creating limits on weights if you are using weights to do some calculations. And also you can use that to create a Gantt chart like this for maybe leave plan, project management, and so on and so forth. So I don't know if you guys have any question, but this is basically what I would just like to show you with the median function. Please, you can unmute and ask questions. The plan here is not to make you bamboozle you. The plan is to explain these things in as simple ways as possible and see how we can find that useful in our work. Oh my. When people don't ask questions, it means it's that they are confused or they are no longer here. So can you guys just say something? Just say something so that we can close this. Sparkle Bash, locally, the boss. Don't know if you have any feedback or question and so on. All right, guys, if there are no questions or feedback, I would like to just wrap it up at this point. Thank you so much for coming around. Thank you for participating in this very short webinar. I hope you find these tips and tricks useful in your work in 2023. And as you use them, I'd really love to have feedback. The video is recorded. It will be on YouTube. By God's grace, I'll put it on YouTube, and then you can always go back to watch it from there. Thank you. Wishing you Merry Christmas in arrears, Happy New Year in advance, and enjoy all the compliments of the season. Thank you.